In just 2 slides, I'll show you by example how the envelope theorem is a shortcut for thinking about the responses of optimizing agents to their environment. Let's start with a little notation, which should be familiar from the microeconomic theory of the firm. N and K denote the amounts of labor and capital, respectively. These factors of production can be rented at rates W and R. By renting these two factors of production, an employer is able to produce according to F. How much will that production cost? That is the question answered by the cost function. The cost function is an answer to an optimization problem, namely, what is the minimum amount of factor costs that can be achieved while still producing an amount Y. Naturally, the factor rental rates affect that cost, as does the required amount of output. That's why W, R, and Y are arguments of the cost function. Another way to write the same cost function is to say that it is the cost of renting the cost minimizing or optimal amounts of labor and capital, where I am using asterisks to indicate optimal amounts. These asterisk quantities are also known as the factor demand functions because they tell us what a cost-minimizing employer would want in terms of factor usage. The factor demands have 3 arguments because they depend on the rental rates and required output. An employer won't want to hire the same amount of labor in a high-wage environment as he would in a low-wage environment. Now let's look at the effect of, say, W on C. The tedious method would be to totally differentiate, accounting for the effects of W on the optimum factor demands. The first term on the right is the direct effect of W on cost by making each unit of labor more expensive. The square bracket terms are the indirect effects of W on cost by re-optimizing the factor demands. The envelope theorem is a shortcut that says that the effect on cost is the direct effect by itself, without any addition or subtraction for the cost effects of re-optimizing. The square bracket term is 0. Re-optimizing, say, in the direction of less labor, saves labor costs, but adds to capital costs, and the two effects are of exactly the same magnitude because we began at the optimum. Conversely, if changing the factor mix could have reduced labor costs without a fully offsetting increase in capital costs, then we had too much labor in the first place. This argument says nothing about the magnitude of the effect of W on labor. If a small increase in W results in an optimally large decrease in labor, then it must also involve an optimally large increase in K. The envelope descriptor can be appreciated in a chart of the cost function versus W. The envelope theorem told us that the slope at, say, W0 is equal to the amount of labor demanded at W0, which is why I have drawn a straight line tangent with that slope. The envelope theorem says that the slope is equal to the factor demand at this point, namely the factor demand when we have wage rate W0. The slope at a larger W, such as W1, is equal to the amount of labor demanded at that larger W, which of course is a lesser amount of labor. The slope of the cost function at W1 therefore has to be less than the slope was at W0. The chart here has drawn 3 of these tangent lines, and the cost function is the lower envelope of all such tangent lines.